Hello everyone, welcome back. We are going to continue our discussion about unit hydrograph. Until now, we discussed what unit hydrograph is, why we need it, and some of the assumptions that are made in the unit hydrograph theory. So what we are going to do today is we are going to look at how we can develop a unit hydrograph. There are two ways to do that, a simpler way and a harder way. We will discuss both, but in this video we'll focus on the simpler way of doing it, and I'm calling this an adjustment factor approach. So let's get started. So the first step in developing a unit hydrograph is to get historical event data, and by event I mean you need data on both rainfall and stream flow. And let's say I found some historical data and I have these three events. The question is, which event should I pick? Now we want to pick an event that satisfies some of the assumptions in the unit hydrograph theory as closely as possible. So if you remember, one of the assumptions in the unit hydrograph theory is that the rainfall has to be uniformly distributed both in space and time. In order to find the uniform distribution in space, you need stations at multiple locations in the watershed. Now in this case, let's assume that we have only one weather station in the watershed, and we are going to assume that spatially the rainfall is more or less the same. So what you see here is the temporal distribution for three different events. So event 1, event 2, event 3. Then the question is, which one should I pick to derive my unit hydrograph? So given that none of these follow that uniform distribution, so by that I mean you need a rainfall event that looks something like this. Okay, so that's like the rainfall is not changing at all, constant intensity over the entire duration. So this is hard to get for most locations, so I'm going to go with this. Okay, so the idea here is to pick an event that satisfies our assumptions as closely as possible. So that's the first thing you need to do. Then once you have picked a rainfall event, then you look at the discharge data. Okay, now for the same event you may have, or for similar rainfall event you may see different types of hydrographs. So again, I'm showing you three different hydrographs here. So you want to pick an event where the hydrograph is nice looking, it has a single distinct peak, and it is sort of have nicer rising and falling limb and so on. So that's again something that you will have to do in picking an event. You want to pick an event where you end up with a nice looking hydrograph, and the rainfall is following the unit hydrograph assumptions as closely as possible. So you want to pick events as many as you can, and that's not an easy task. So for now, let's assume we found at least one event that satisfies our criteria for unit hydrograph. Okay, so that's your first step. Your next step is to now calculate the direct runoff depth from the event you picked. Okay, so remember when we discussed unit hydrograph, we put a lot of focus on excess rainfall and the direct runoff hydrograph. So what we have here is a total streamflow hydrograph. Okay, so from that total streamflow you want to separate the base flow. Okay, separate. And by now you know how to do that. We discussed multiple techniques to do that. So once you separate that base flow, you end up with the direct runoff hydrograph. Let me use a different color. Okay, so this was our total streamflow hydrograph. And from that total streamflow, we separated base flow, and what we have here is direct runoff hydrograph. Okay, once you do that, your next step is to compute the volume and depth of direct runoff hydrograph. Okay, which means that besides the rainfall and stream flow data, you also need to know the area of the watershed. Area of the watershed is also needed. Okay, so that's another data requirement, and that's easy to find, so that's why I did not put much attention to that in the beginning. And in our assignment 12, we looked at how to compute the volume of the direct runoff hydrograph. So we do that, and let's say the volume of this, so volume, or let's say depth, is equal to, let's say, 2 inch. Okay, so if it was 1 inch, then we would have gotten our unit hydrograph. So that's what a unit hydrograph is. The volume under that curve is 1 inch, and inch is a depth, but we convert the volume to depth by dividing it by area. Now, since this is not 1 inch, this is 2 inch, or let's say it is x inch. Okay, so if x is equal to 1, then we have a unit hydrograph. We don't need to do anything. But if x is not equal to 1, so in this case what we have is x is equal to 2. So what you do to this direct runoff hydrograph is you multiply this. So I'm just going to draw that one more time here. So QT, so depth x inch. Okay, so what you do then is you multiply this by 1 over x, and then that will give you the unit hydrograph. So let's say if this was Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8. So you multiply each of these Q's by 1 over x, and then that will give you your unit hydrograph. Okay, because in this case everything will, the total depth under this curve will be equal to 1. Okay, so we got the unit hydrograph. Now if you remember the definition of unit hydrograph is always associated with the duration. The question now is, what is the duration of this unit hydrograph? To do that, we'll go back to our rainfall event. Okay, so remember the depth of the direct runoff was 2 inch. So I go back to my rainfall data set, and let's say the total depth of this rainfall, let's say it's 4 inch, and our direct runoff hydrograph gave us 2 inch, which means that the 2 inch of rainfall was lost from this event as infiltration. So what you do is you subtract that loss from this rainfall hydrograph to get your excess rainfall hydrograph. So for now, I'm going to assume that this is 0.5 inch, and I want to get rid of, or let's say for now, just to keep it simple, I'm going to assume that everything under this is 0.5 or 2 inch. Okay, so 2 inch of loss, and we are going to discuss how to draw this line so you get the loss that you want. And after I draw this line and get rid of all the loss, I'm left with 4 pulses of rainfall, and now you can see this sort of looks more or less uniform. And if delta t in this case was half an hour, I end up with 4 pulses of half hour excess rainfall, which means the duration that I have here is 2 hours. Okay, so let's also say delta t is equal to 2 hours, or half an hour. And because after subtracting losses, I'm left with only 4 pulses, and they last for 2 hours. So if I think about it now, then you can see that we have sort of more or less uniform rainfall for 2 hours, and from this 2-hour uniform rainfall we got this unit hydrograph. So this is a 2-hour unit hydrograph. Okay, so that's how you can derive a unit hydrograph if you have historical rainfall and stream flow data. Now, what I have shown you here is sort of ideal situation. So we were able to get more or less uniform rainfall data, and you were able to find a nice looking hydrograph and all that. Many times you don't have that kind of luxury. So if you don't have a nice looking data set, then you can use another approach, which is called the deconvolution approach, which we will look at in our next video. But here I'll just write the name, deconvolution approach for unit hydrograph. Okay, so that is something that we will do later. The other thing I want you to also know from this is that we end up with a unit hydrograph which is of 2-hour duration. So what this means is that you can only use it when you have rainfall that also lasts for 2 hours. If the rainfall doesn't last for 2 hours, you cannot use this. You have to use a unit hydrograph of different duration. Then again, the question is, how do you convert a unit hydrograph for one duration to another duration? And that is also something that we will see later. Okay. One last thing I want you to know from this is that what I have done here is I have developed a unit hydrograph by using data for one single event. So ideally, you want to repeat this process for as many events as you can, and then you end up with multiple unit hydrographs. And what you do then is you take an average of those, and that average unit hydrograph becomes the unit hydrograph for that particular watershed. So this is how you can develop a unit hydrograph for a watershed. And I'm calling this an adjustment factor approach because we adjusted our direct runoff that we got by a factor to get our unit hydrograph, and that factor was 1 over the depth of the direct runoff that we got for this. Okay, so this is all, and I hope you are able to follow this process. I'll just zoom out and you may not be able to read this. What I have done for you is I have listed these steps here. So if you follow all the audio and the video and and all that I have done, I have listed here in these 8 steps, and I think this is the procedure I followed. And I hope you are able to create a unit hydrograph for an event, and we are going to do a assignment on this later. So with that, I'll stop here, and as always, if you're not able to follow anything or if you have any questions, feel free to email me. Okay, thank you and bye.